So amplification is one of the most important concepts in electronics, and basically it's the idea that if you put in a small signal, you may be able to get a larger signal out. And so that's shown usually with a graph like this, where you start out low, have some low value, have some sort of linear or nonlinear transition up to some higher value. And so the way that this is shown is you put in some small x value here into this around this like Q point, as it's called, or like the operating point, and as this x value changes, this y value will change much more. So you get these much larger waves, and effectively you're amplifying the signal as it goes. And there's a couple ways to do this. One of them is with op amps, that's for more macro scale circuits. But you can also do this with MOSFETs and BJTs, which are bipolar junction transistors. But they all can do the same purpose, just with different equations. Another point to make is that if you have some sort of linear transition, then this sort of amplification can be done anywhere up to this like difference between high and low, this like x-axis. Then you can really do anything within that, and it'll amplify linearly. But if you're operating with, let's say, a nonlinear, something like a diode, then you may want to choose an operating point that's somewhere in a relatively linear region, and you're only going to operate at small like distance x values, because only there can it be approximated as linear. The smaller scale you go, the more linear it'll be, and the better your approximations will be.